All right, so now I'm live. I believe now I'm live. Can you please message, comment if you can hear me? I'm so sorry. Can someone please comment just to say that this is live and that this is now working? Because I don't see any chat activity. Great, thank you. Dahlia, thank you. Good morning. Awesome. I hope everyone had a good week. Yeah, it's Friday, the first week of remote learning. So just long and short of why I was having issues. Every school, I guess, is using Google Classrooms. My school is using Microsoft. So it's actually, I think it's a little bit better than what we're using now, but that's debatable. But I'm just happy that we're able to communicate, period. So I'm hoping that you found the homework somewhat easy. I posted the solutions here. And if you have any questions, I'll try to go over one or two examples, but I think this was pretty clear. Just let me know, though, please. And good morning, Gianni. Good morning, Eleni. So again, are there any questions related to the homework? All right, I'm going to take that silence as no, which is good because you should have found this to be pretty simple. So I'm going to move along now. And, let's see, hold on. Okay. Good morning, Valentina. All right. So moving along. So basically what we did on Tuesday was we divided a polynomial by a binomial. And the variable, or the coefficient of the variable x, was typically 1. And that we're going to continue looking at that. But if we look here at this special case, so essentially a function of x, or the function of x in this case is a polynomial. We can rewrite it to look like this. So it's okay if it looks kind of confusing. It's saying here f of x is equal to x minus k times q times x, or q of x, excuse me, plus r. So I'm going to go to my digital whiteboard right now. Just please let me know if this works. You should have the link. If it works, please tell me what you see. Oh, can we do 4? I'm so sorry, Leah. If I have time, I'll try to do that. I saw that comment late. But if you look at the whiteboard, can you just write what you see? Or just comment what you see? I want to make sure that it's up and running. I included a link to the whiteboard in the post. Great, thank you, Sarah. So we're good. So basically, right now, this is what you see in front of you. So this may look like a bunch of gibberish or nonsense. However, what you really had to do for homework was this. So you had some function of x, and you were dividing it by x minus k. So here what I'm going to highlight in red, this was your homework, to do that. Now if you look here, I'm only pointing so that you could see. So basically, if you divide everything by x minus k, look at what you're left with. You get to cancel this out here, or this reduces. I'm sorry. But let me go back. Can I go back? Yes. So that goes away, but I'm dividing x minus k into both of these pieces here. So when I do that, and remember, now you have to follow me. We're going to bring this down. So when you follow me, what you're left with is this. Darker on the whiteboard. Thank you, Valentina. So I'm basically going to rewrite this. F of x divided by x minus k. All of that will equal to the quotient of r plus some remainder divided by x minus k. So basically, what you're looking at in the PowerPoint, what's being shown here, is not this. So this is what you had to do for homework. This should have been the format of the responses for the homework. So what is being shown now is that the format, or what should happen at all times when you do end up dividing over here. So when you basically do this, here I'm highlighting or circling this, it will really be the following. Again, follow along. It will really be f of x is equal to basically the denominator that you had before, multiplied by the quotient, the quotient of r plus quotient of x. So this is what we call the division algorithm. So you did it yesterday, you did it on Tuesday. The only thing here is that it's expressed differently. So if I just go back, or if you scroll back up for a second, and you can fit both in your screen, you're just looking back up. So both of these are the same. They're just written differently. So if we look at what we need to do today, so this is an example. So if you look at this example here, you have f of x to the left and then the division algorithm to the right. So what you have to think about is imagine dividing x plus 2 on both sides. So in other words, I'm going to just rewrite it here just so you see it. So we're going back to the whiteboard. I'm not sure where you're looking, but in red, I'm going down this way now. Going down. Follow me. Going here. Are there any issues so far? I'm looking now. Okay, good. If you have any questions, I can stop. Just let me know. So if you look here, I'm just going to write this quickly. 5x cubed minus 6x squared minus 28x minus 2. So that's on the left-hand side. But if you divide all of this by x plus 2, you could do this now based upon what was done for homework. You can do the synthetic division and you'll end up with an answer. What answer? So if you look to the right-hand side, so I'm just going to move this now in this direction. So if you want to follow the board, I'm moving here. So all of this will equal to x plus 2 times 5x squared minus 16x plus 4. But I can divide all of that by x plus 2. And that's going to get rid of this. And we're moving again in this direction because I've run out of space. And then we're going to add that with the remainder. And the remainder here is negative 10, but you have to divide that by x plus 2 because it's the whole right side divided by x plus 2. So basically what I'm going to now circle in purple, so all of this that's in purple, that's what you did for homework. So if you look at the purple, what I just circled in purple, 5x squared minus 16x plus 4 plus negative 10 divided by x plus 2, that's what you did for homework. What you're looking at now in the example is the same exact thing, but it's just written differently. And we call this in the format of the division algorithm, but what we can do is we can use this format to get to what's called a remainder theorem. So in other words, a way of performing some type of mathematical operation that will give or produce less work. So let's look here. According to the remainder theorem, if the polynomial f of x is divided by x minus k, the remainder is equal to f of k. So that may sound kind of weird right now, but hopefully you downloaded the materials. Actually, the materials for today will be the back of the handout that you were working on Tuesday. I don't know how many of you printed it, but if you printed it, you would just turn it around, or it would be a second page. But if you're using the PDF, the actual file, you just scroll down and you'll be on the next section. So here in example 1, let me see if I can get rid of this so it's not giving too much away. So we have the following. So if we look at 5x cubed minus 6x squared minus 28x minus 2, and if we were to actually divide it by x plus 2, the k value is negative 2. So what I want you to do basically is to evaluate this function. So I'm going to go back to the board here. So here I'm going down. So if you want to follow along, I'm going to do the following. So here's this function f of x. It equals to all of this. And what I want to do now is basically evaluate it when k, or in this case x, is negative 2. So I want you to do that now. So take a moment, rewrite this somewhere in your notebook or on the handout itself, and you have 5 times negative 2 cubed minus 6 times negative 2 squared minus 28 times negative 2 minus 2. So I want you to do that. So take a moment, substitute in, evaluate. So if you do that, what's going to end up happening is this. We end up with negative 10. So f of negative 2, I'm using my whiteboard now, equals to negative 10. So in English, so this is still a little bit confusing. So in English, here it goes. You plug in the k value into the function. If you have a value that's not 0, you have a remainder. So again, if we're dividing a polynomial by a binomial in this case, and we plug in the k value, in this example, the k value is negative 2. The fact that we get a negative 10 tells us that we have a remainder. So this is basically what's called the remainder theorem. So we could have done the synthetic division. So again, just for time's sake, I'm not going to go through it step by step, but if you wanted to do it, it would look as follows, and we're basically looking here where my pointer is kind of going crazy. Hold on, let's see. Oh, Mr. Pacell, good morning. How are you? Welcome. Welcome to our remote learning. This is nice. So when you look at f of negative 2, it's going to give us negative 10. So if we were going through the synthetic division process, that negative 10 would have been divided by x minus k in this case, which would have been x plus 2. So what I want us to now do, I don't think this example was given to you in the handout, and I apologize for that. I thought it was, but this is now the true example. So if we look at example 1, so let me just get rid of this here. I know it's giving away a little bit. Maybe you already did it, which is okay. Nothing wrong with that. But what I want us to do, let's look at example 1, and what we really want to do is to determine if there's a remainder. We can do that by the whole synthetic division, or we can just plug in what we're going to find out now. Let's see, use the remainder. Right, so here we're not really dividing much. So what I want us to do is I want us to plug in -3 in for f of x. So take a moment to do that. Because as you're doing this, something that you should be thinking about, there's no denominator here. We're only given the polynomial and then a value for x. Later on, we're going to use that value of x to find or to determine what that denominator would be. So take a moment to plug in f of -3. And you're free to evaluate, or you're free to chime in with the solution. So if you have it, it'll be great for you to share it. Anyone, actually. Can someone in the class participate and give us a solution, or what happens when we evaluate f of -3 in this equation? -47. Oh, wow. Keep it going. Maybe someone has something different. Nice. Thank you, Sarah, Irene, and Leanna. So let's see. So if we plug this in, so here we could have used a synthetic division. You could have. Because that you're being told now that this is your k value. But if you just plugged in for f of -3, you would have gotten -47 anyway. But given what you have there, so you have that value of -1, 3, -6, 14, and -47, that would actually give you the quotient when you would be dividing that polynomial by the denominator. But in this case, it's not really clear what the denominator is, but maybe you could figure it out now. So that would actually be a good question. So I'm extending a question here. So what is f of x being divided by in order to get all of this information that we have in front of us? So I'm extending a question. So we go to the whiteboard. So let's consult the whiteboard. So I'm going to move down. Look at that. Look at that. I love the contributions. And that's perfect, actually. So thank you, Kyle. Thank you, Leanna. Thank you, Sarah, Tenzin, Irene, Eleni. So you're doing great. So basically, if you look here at the whiteboard, when we have that k value, we're actually dividing it by x plus 3 in order to get the remainder of -47. Because in this case, k will equal to -3. Wait, so let's see. I have a question here from Valentina. Thank you. So if you want to use long division, would you use x minus 3 to divide the function, or just plug in the negative 3 to the function? So long division, x plus 3 is still going to be the denominator. So that's number one, or the divisor, if we're going to use another vocabulary word. So here's the thing, and you asked a great question, Valentina. So do we go through the whole process of synthetic division or long division to find the remainder? It's an option, but according to this remainder theorem, so again, this is where we have a binomial and the coefficient of the x value is 1. So it's linear, and we have that coefficient of 1. When we plug in the k value, it's going to allow us to find the remainder without having to go through the process of long division or synthetic division. It's just a shortcut. Think of it that way. You want to know if when you divide a polynomial by a binomial, if there's going to be a remainder, you're going to do this. You're going to plug in the k value into the function, and then you'll have an answer. If you have an answer that's not 0, you're going to have then a remainder. So if you look at the next set of questions here, the try on your own, pick at least 2. Pick at least 2. I don't want to take too much time with this, but if you look at these examples here, so it does say to do the synthetic division, but for time's sake, I just want us to determine if these examples here are from within this group, which ones have a remainder. And for time's sake, you can ignore 4 and answer 2 from questions 1, 2, and 3. In fact, it may take you like 2 minutes to figure this out, but I'll give you 5. So right now we're just working on try on your own. You can ignore 4, but you can definitely try it if you'd like. But pick at least 2 from question 1, 2, and 3. And what we're trying to figure out is, given these functions and those specific k values, if we have a remainder. Did that answer your question, Valentina? I hope I answered the question. I'm not sure if you heard me. So again, we're trying the questions that are there. I'm going to give you a few more minutes. You should see that it's not going to take too long. Oh yes, thank you. Awesome. Glad to hear. So I'll give you about 2 more minutes. I'm pretty confident that most of you finished 1, 2, and 3. If you'd like, you can take an attempt at number 4, but I'm not really going to spend too much time going over that. It's more of an extension, but it's essentially, a review of imaginary numbers. 2 and 3 have remainders. For 3, I got 127 when plugging in k equals 4. Hey, the class is now yours. So anyone in this chat, you can agree with Kyle, you can agree with Josh, you can disagree. The floor is open. Feel free to confirm those answers. Feel free to share what you have. And thank you again, Kyle and Josh, for sharing that. Sorry if my computer's going a little slow. My computer's acting up. I have no idea why that happened. But I'll keep the other one. I agree with both. One has no remainder. Sarah agrees. All right, so let's see what happens. So in looking here, hopefully this popped up. Sorry, the computer's really acting up today. Did it change? Oh, there we go. Great, perfect. Sorry for that delay. So any questions so far? So again, if for number 4, I wouldn't worry about that too much. But if you happen to try it, then you would have seen that that was the evaluation. So moving along. So all of this is going to relate to something called zeros. Oh wait, hold on. Do you want us to upload work for classwork? So no, at this case, or as of this time, I'm okay with you not doing that. So again, I'm answering Valentina's questions to upload work for classwork. So I'm still, kind of evolving within this system. So at some point, probably, again, I'm kind of limited here only because, maybe my computer's slow. It's a little bit of an older, MacBook. It's not really, I guess, that optimized for streaming. And, in time, maybe I will change that. So right now, the screen that you're seeing, testing potential zeros. So I changed slides about 15 to 30 seconds ago. So there's a huge lag. So if you're going to upload work, you can do that certainly in the Google Classroom end, but if you want me to upload work to display to the class, to highlight, I would love to do that, but just given my current capacity and the technology that I have here, it's just going to run so slow. So for now, whatever classwork you do share, you can do it in the classroom. I think that's fair. And I think your post will go live so that this way your classmates can see, and I'm okay with that. Is it a typo, Josh? It could be a typo. If that's the case, then I'll have to correct that. And let's do that. Anyone want to chime in? Is it zeros or zeros? So it's debatable, but it's not incorrect to have it this way. So both are actually okay. So a zero of a polynomial function. So if we look at this slide, so basically what we want to figure out is this. Because if you looked at the solutions, you did have a zero in there. There was no remainder. So then the question really now with regards to what we're doing within this slide is, what does that mean? You know what it means when you have a remainder, but what happens when you don't have one? So the remainder theorem gives a quick way to decide if a number k is a zero of a polynomial function defined by f of x. So another way to think about this, and maybe you can write this as a note, that if your remainder is zero, then your denominator, or what you're dividing by, is a factor of the polynomial. So again, let me repeat that. So if you have a zero, or if you plug in the k value and get no remainder, then the denominator, the divisor, if you will, or what you're dividing the polynomial by, is a factor of the polynomial. Class is over. I have about 2 more minutes. Right? This ends at 45? So, in other words, here, so I'll go through this one last example and we'll stop at 45. I have 943 on my end. So, if we look at this example, so we're trying to determine if k is a zero. Oh, it's 42. Oh, okay, so my mistake. So I apologize. I thought it was 45-minute classes. So see, time goes quick, and I also had some technical difficulties. So the long and short of it, so if you plug in the k value and you get a zero, that means that you have one, no remainder, and that what you're going to be dividing by. So that actual denominator will be a factor. So just to look at here, what we have, since k equals 1 results in a 0, then that is going to end up becoming a factor when we rewrite the k value as a true denominator. So we'll end it here. I'll have homework submitted or posted online or in our Google Classroom, and we'll continue where we left off today. I hope you guys have a great weekend. Stay safe, stay healthy, and we'll continue this on Monday. Have a great weekend too, Irene, Leanna. Stay safe, everyone.